In this video, we're going to look at how to find measures of central tendency, and in particular, how we can use technology to help us do this. While it is possible to find all these measures by hand, the reality is why when we have calculators that will do it for us. For this video, I'm going to focus on how to use the Desmos graphing calculator to find these values. If you want to know how to use a TI-84 graphing calculator or another online statistics calculator, check out some links on Canvas. I have instructions on there. All right, so we are given 8 data points here that represent the cost of energy bars at 8 different grocery stores. And what you see on the left here is I've already entered this data set into my Desmos calculator. And you'll notice to enter a set in Desmos, you use brackets and then separate each number with a comma. I like to name my data sets because it will actually make it easier when I go to find the calculations. As mentioned earlier, there are 3 different types of measures of central tendency, and in different situations, all of them could be thought of as quote-unquote averages, or this best way to describe what is the center of our data. Probably, though, the most common one for data for average is this concept of mean, and often is used interchangeably with the word average. A mean is basically the value in a data set. If you imagine that all 8 data points were the same value, the mean would be that value. So if I want to find the mean of my 8-point data set, I could add up all 8 numbers and divide by 8. Or in my Desmos graphing calculator, I could type the word mean or go under functions. And notice right under statistics, the very first one is mean. And then if I type in the letter of my data set list, out pops my mean value of $1.41 for that cost of that energy bar. The next measure of central tendency is known as the median. And if I wanted to find the median by hand, I would need to organize my data from lowest to highest, which I already have, and then I sort of count off. So it's like I have 0.1 and then 0.1 and then 2, 2, 3, 3, and then I get my middle here. If there was actually a middle number, that would be my median. But in this situation, since I had 2 numbers, I would actually find the mean of these 2 numbers. I would find the number that's basically between these 2, and that would be my median. And I would do that by adding them and dividing by 2. So I'll just make a note of that. So I could find this by doing 1.35 plus 1.39 and divide it by 2. The quicker way, of course, again, is to use my technology. We have it, so we might as well use it. And still under that function statistics menu, you'll notice the second value there is median. And again, I'm going to type in my list name, which is A. And so we'll notice the median here is $1.37. So a little lower than the mean. Not a huge difference, but slightly lower. And then the last measure of central tendency is known as the mode. The mode is the most common value, and that you really do need to just find by hand. And it's easiest if the numbers are in order, because like in this case, and I'm going to switch colors here just so I can see it a little clearer, you'll notice, there's no other $9, so that's out, and there's no other $79, but I'll notice there are 2 $29s, and no other value repeats. So my mode would be the most common value, which is $1.29. It is possible to have multiple modes if a number occurred the same amount of times, twice or 3 times. But in this case, we just have one, and it's given to us that $1.29. All right, so then the next question is asking us which measure of central tendency would be the best way to describe that average data. Like I want to describe sort of what is the average cost of an energy bar. Now, the big thing when thinking about what measure of central tendency is the best to use is to think about if there are outliers. Outliers are numbers that are far from the rest of the data, the numbers in the data set. And for right now, we're just sort of going to do it on gut instinct. In a future lesson, we're going to talk about how to mathematically figure out if a number is an outlier. But if I'm looking at this data set, none of the numbers is particularly far away from things. You know, you might be thinking, oh, that 179 seems really big, but it's only 20 cents away from 159, which is the same distance I have over here between my first two numbers. So I would argue that there are no outliers. And if there are no outliers, the tendency is to go with the best measure is the mean, because that's the one that people are most comfortable with. If I talk about finding sort of the middle value in a data, people almost naturally assume the average. So unless I have an outlier, I'm probably not going to say the median. Is the median, maybe is good? Yeah. Maybe it's a little more descriptive because we have that mode down there in the lower end, and you could argue that that's equally good. But typically I'm going to say the mean, since there are no outliers in the data set. Okay, so what if there was an outlier? Let's say hypothetically we get an additional store, and this store charges $2.50 for that energy bar. So we're going to get a whole nother data point here. And you'll notice that this new data point is a huge way away from the other data point. So we would think of it as an outlier. So the question here is, how does that outlier impact our data? So let's go into our data set, and we're going to refine the mean, the median, and the mode, and look at what happened and talk about what happened to our data. Well, let's start with the mode. The mode's the most common number. That 250 has no matching pair, so my mode doesn't change. And in fact, modes shouldn't be impacted by outliers. So no impact. All right, let's go though into our data set here. And I'm gonna scroll over to the end of it. And I don't have to, but you could consider it just sort of, I like to be at the end, and I'm gonna put a comma, 250. I'm going to add that extra. So you'll notice now it has 9 numbers on the data list, and you'll notice my mean and median have changed. And I didn't have to re-enter anything because they're associated with the list name. And my mean now is $1.53, and my mode is $1.39. So my median, is $1.39. Both the mean and median changed, but the median didn't change by that much. It went up by 2 cents. But if you remember, that 139 was one of those 2 values that we used to find the original median. So really, it's not a huge change. It's a small change. But the number that really was impacted was that mean value. Notice the mean's now 12 cents higher. So this had a big impact. And that's why when we say, what measure is the best way to describe the center, if we have those outlier points, we really don't want to use the mean, because those outliers are going to have the largest impact on that mean value. In fact, often if there are outliers in data sets and we want to find the mean, we're going to throw the outliers out of the data set so that it doesn't have quite such a big impact on our sort of measures of central tendency. So hopefully you have an idea of how you can use technology to help you find these measures. And if you click on to the next slide, you'll have an opportunity to try to find the mean, median, and mode on your own.